Hi, my name is Lisa LaRue, and I made this Skillshare video to go over how you can make an ERD in MySQL. ERD is the acronym for Entity Relationship Diagram, and MySQL is the Database Management System, or DBMS, that we'll be using to create our ERDs. Before we get into it, I'll cover some key terms and concepts to provide important background information on the topic, such as database, conceptual design, logical design, entities, relationships, cardinalities, and attributes. If you're already familiar with these concepts, feel free to skip to the last portion of the video where I'm actually working in MySQL. So we'll start with the basics. A database is a shared and integrated collection of interrelated, self-describing data. It's usually designed to meet the information needs of multiple users in an organization. It is important to distinguish between a database and a repository. The repository contains definitions of data, whereas the database contains the occurrences of data. A database can be of any size and complexity. For example, a salesperson might maintain a small database of customer contacts on her laptop, or a large corporation may build a large database consisting of several terabytes of data on a large mainframe computer that can be used for decision support applications. Very large data warehouses contain more than a petabyte of data. A petabyte is a quadrillion bytes. There are different types of databases, but in this video we're focused on relational databases. Relational databases stores data in a structure consisting of one or more tables of rows and columns which may be interconnected. Some of the advantages of using a database instead of a standard spreadsheet are that it can reduce redundancy, it allows for sharing of the data throughout an organization, it reduces the risks of inconsistencies, and it improves data accessibility. Like I mentioned before, the database management system I'll be using in this video is MySQL or MySQL. A DBMS is a software system that's used to create, maintain, and provide controlled access to user databases. Popular relational database management systems include MySQL, Microsoft SQL Server, Oracle Database, IBM DB2, and Microsoft Access. Now that we know why we might want to use a database management system, we will start thinking about the requirements analysis. In the requirements analysis, we collect users' requirements and write requirement specifications as simple as the following paragraph. Employees are assigned to projects. For each employee, we record their employee ID, first name, and last name. For each project, we record a project ID and project description. One project must have at least one employee. One employee can be assigned to at most one project. So that's our example. The conceptual design will turn the requirement specification into a database model. The most common conceptual model used in relational database design is an entity relationship model. And this is a ER diagram or ERD for the described requirements specification. You can create this conceptual design by hand or using a program such as Lucidchart. A conceptual data model represents data from the viewpoint of the organization, independent of any technology used to implement the model. After decades of use, the ER model remains the mainstream approach for conceptual data modeling and is most used as a tool for communication between end users and database designers during the analysis phase of database development. In this video, we cover the basic elements of the ER model. The ER model is expressed in terms of entities, which would be the project and employee, as you can see in this example, the relationships or associations among these entities, and the attributes or properties of both the entities and their relationships. An ER model is usually expressed as an ERD, which is just the graphical representation. The ER model continues to evolve, but unfortunately there is not yet a standard notation for ER modeling. In this video, I'll be using crow's foot notation. The entity type, or called entity also, when implemented into a database, usually corresponds to a table. Anytime we say entity, it really means entity type. Only when we say entity instance, we're talking about the specific ones. When we say customer, the customer is an entity, but we can have James, Jane, Jay, all different customers. So each one of those is an instance of a customer, and each one is individual specified. Those would be the rows in our table. The symbol for an entity is a rectangle. Each entity type has a set of attributes associated with it. An attribute is a property or characteristic of an entity, and the symbol is just the text inside the rectangle, which is listed under the entity type name. Here, our attributes are Social Security number, name, and account number. Relationship type is a set of associations among entity types. Each relationship type is described by a name. In our example, this might be the customer entity buys the product entity, or that the product is purchased by the customer. These are two names for the same relationship type, and you can choose to use either both of the names or either one to label the relationship. However, most people just write one name, either reading from left to right or top down. The last important data modeling notation for representing common and important business rules is cardinality constraints. This is the number of instances of one entity that can be or must be associated with each instance of another entity. The minimum cardinality can be optional or mandatory, and the maximum cardinality is either one or many. I think this is a little easier to understand by looking at a few examples. So for the first example, the project must have at least one employee, and one employee can be assigned to at most one project. So this is an optional one to many. As you can see, reading from left to right, the project has at least one employee, is indicated by the line drawn on the relationship line closest to the employee entity, and the line splitting into three after that indicates there can be more than one employee. Now reading from right to left, so looking at employee to project, we can see the employee may have one project, as indicated by the optional circle on the relationship line, and the maximum projects an employee can have is one. This is indicated again by the line drawn across the relationship line closest to the project entity. Another type of cardinality a relationship may be is one-to-one. This means each entity instance in the relationship will have a maximum of one entity instance. In the example shown, each student can at most have one account, and each account is owned by exactly one student. The last relationship cardinality is a many-to-many relationship. This means that entity instances on both sides can have many related entity instances on the other side. In this example, each student can take 0 or up to 6 courses, and each course can enroll 10 to 50 students. So this many-to-many is related to the maximum cardinality. In the logical design phase, we turn the ERD into the formal table design. We determine how many tables we need, what columns are in each table, and how to link these tables. The two figures are the logical design for the given ERD that we are just looking at. The left figure is a general diagram of a list of tables, and the right is the MySQL version of this design. This figure is very similar to the conceptual design, but they're actually different. The logical design shows the duplicate columns, which are called foreign keys, to link the tables. A foreign key is an attribute in a relationship that serves as the primary key of another relation. I don't know if that's clear, if I said that right, but the foreign key references the primary key of the other table, so you can use them to link the records of two tables together. In the general diagram of a list of tables, the foreign key is labeled using a dashed underline, as you can see in the left image. Project ID is the foreign key. In MySQL Workbench, the software will create the foreign key for you automatically when you draw the relationship, and it'll mark the foreign key as FK, as shown in this image, or using a different color depending on your settings. To get started with turning our conceptual model into a logical design, first I'll show you how to create a simple entity. Here's an example of a customer entity with the primary key being customer ID and the customer name and address being the other included attributes. On the right, you can see the logical design derived from this conceptual design. So this is the first example I'll go over in MySQL. Next, we can create an order entity table in MySQL to use the dotted line function or button in order to create a one-to-many relationship between the two entities. I'll go back to the slide in the previous when we're creating them in MySQL for reference. And then in this third example, we'll go over how to create a many-to-many relationship. This example shown is also an example of a relationship attribute because the unit price attribute pertains specifically to the raw materials supplied by the vendor, and therefore its value is different for different vendors and different raw materials. Note that the many-to-many cardinality between entities has been replaced by two one-to-many relationships with an associative entity created in MySQL automatically, with the cardinalities being swapped between the two. If this isn't clear, you'll see how it automatically creates it when I create a many-to-many relationship in MySQL. Okay, so now that we've covered all of these concepts, I'll share my screen and quickly go through them on MySQL. Okay, so first I will open MySQL, and you click on your schema that you want to use. There are other easy to follow resources on how to create one if you haven't already, so I'm not going to get into that for this video. And then you're going to go to File, new model. When it opens, click on the icon with the plus sign that says new diagram when you hover over it. Let's see. Now we have our blank template to create the ERD as a logical design. To create our first entity, click on Place a New Table button. And then you have to click into the window. And let's refer back to our first example to see what we're going to put into the table. So we have customer as the entity, customer ID as the primary key, and then the name and address as the attributes. Okay. So now just double clicked on this, changing the table name to customer, and then click in here. It's going to be customer ID, right? Yes, ID. And then you can see that was automatically created as the primary key because it's the first attribute that I put in. And then we have customer name. And I'm just double clicking the rows to create the new attributes. And customer address as the next one. And these data types, int is integer, variable with character limit of 45 is fine for these ones, I think. So I'm just going to leave those data types as they are. And then I will close this, and actually I'm going to change my model, go to model options, diagram, I'm unclicking use default settings because I want to not show the column types, and I do want to show captions for the relationships. Okay, so now it should be similar, and you don't have to do that. That's a preference thing. Yeah, so that's similar to what we see on the right side right here. Okay, so that was simple. Our next example is creating one-to-many relationships. So we have our customer entity. Now we need to create our order entity with attribute primary key being order ID, and then another one, order date. Okay, order ID and order date. So we'll again click on this table, click on the window right there, and then this is going to be order ID, and order date. Again, you can see it was automatically putting the first attribute as the primary key, which is what we wanted. And then we have a many-to-one relationship. When you create this relationship in MySQL, you start off with the many, and then you click on the one, and it's going to be a dotted line. So we can see here's a dotted line and one-to-many. We're starting on the many side, and then we click on the one side. And it's a little weird. I won't bother with that. I was trying to make it a straight line, but it's okay. You understand. and I double clicked this automatically generated relationship caption, and I'm going to change it to submits. And let's see what else we need to do. So we have mandatory on this left side by customer entity and optional by the order. So let's go to foreign key, mandatory by the customer, and optional. So I'm unclicking the mandatory for order, and let's just make sure that was done correctly. So as you can see, it created this foreign key. The primary key on the customer side becomes the foreign key on the order side, because that's the mini side and this is the one side. So yeah, that's that example. And for our next example, and this is the last one I'm going to cover today, is the many-to-many relationship. So we need raw materials and vendor. I'm actually going to do like a split screen so I can see this a little bit easier. So we will start off by creating the two tables. Again, it's this little entity button. And then we want to make the first one called raw materials. Primary key is going to be material ID. Another attribute is standard cost. It doesn't really matter what order. As you can see, there's a different order of the attributes on the table on the left. So as long as we have all of them included, it's fine. Okay, and then that's it for that one. And we want to create another one. What's the second one? Vendor. Okay, so this one is vendor ID, vendor name, and vendor address. And just making sure that is consistent. Why does this look like that? Maybe it'll update and look better. There we go. Okay, and then for our many-to-many, if it doesn't show up on your screen, you can click this little arrow and line, and then the relationships show up, or you can just exit the table and then they show up too. So whatever you prefer. We're going to be doing many-to-many, so that's N into M, and I don't think it matters which one you start with. Okay, so these are kind of messy to begin with because it has these automatically generated names. We just want this one to be is4. So I double clicked it, and then double click the next one and change the caption to is from. And then the last thing we need to do, no, not the last thing, we need to click on this newly created entity, which that's what I was trying to describe before. It automatically created it when I went to create the relationship. But we're going to call this quote. And we need to add unit price to here. And you can see it automatically made these primary key and foreign key for the new entity, which we're calling quote. And now the last thing is to, where is this? Oh, is to go to these relationships, double click it again, and make sure we have our mandatory or optional buttons clicked correctly. So for this one, it is supposed to be mandatory on both sides, but for the is from relationship, it's not. So we need to make the quote side of the relationship optional. All right. So now it matches what we were supposed to create. That is basically it for this tutorial. And let me know if you have any questions. Thank you for watching. I hope it was helpful. And a huge thank you to the professor for database design and implementation. Pretty much all of this information was derived from the material I learned in her class. All right. Thanks for watching. Bye.